Okay, today we're going to look at similar figures and review those. Now that was something that you guys must have learned in the past, and since we're going to be using this concept, we're going to review it right now. So, if two polygons are similar, then their corresponding angles are congruent, and the lengths of the corresponding sides are proportional. Okay, corresponding just means having the same position. So this angle right here is corresponding to this angle because they're in the same position. But we'll look at that on the next example. It makes more sense. And then it says corresponding lengths. The lengths of corresponding sides are proportional. So let me show you guys what that means. When we set up proportions, we're setting up two fractions or two ratios that equal each other. So what you just want to make sure of when you set up these proportions is that the numbers that are in one fraction that are on top of each other, those ones are related. But then you also have to make sure that the ones across from each other are related. Let me show you what I mean. 40 is related to 25 because they're both the hypotenuses of the right triangles. So we would put 40 over 25. It doesn't matter which one you put first. You could say 25 over 40 and switch the two. And then we would say that 32 is proportional to 20. So we would say 32 right here and then put 20 right there because those two sides are corresponding. So how are they related? Well, these ones are corresponding sides, which we kind of already talked about. And these ones right here are related because they're from the same triangle. Now if we look at the bottom, these are also related because they're from the same triangle, and these are related because they're corresponding sides. So as long as there's a relationship between the ones that are on top of each other and the ones that are across from each other, your proportion is accurate. So does 40 over 25 equal 32 over 20? Well, let's see by simplifying. For the 40 and the 25, we can take out a 5 from both of those and we get 8 and 5. For the 32 and the 20, let's see, I can take out a 4 from both of those. 32 divided by 4 is 8, and then 20 divided by 4 is 5. Whoops, I said 5, wrote 4. So 8 over 5 equals 8 over 5. So we have a proportional figure, or proportional triangles right here. Let's look at the next polygons that we have. Here we have two four-sided polygons that you guys know as rectangles. Now we got to see if they're similar. So we look at the corresponding angles and the corresponding sides. Well, since they're rectangles, all the corresponding angles are going to be the same. Now what about the sides? Let's see. It looks like we're only given these two and we're only given these two sides. So we're going to assume that this is corresponding to that and this is corresponding to that side. So let's write them out. Let's go 18 over 25 equals, so it's 18 over 25, and then so let's do 36 first, and we'll do 45 for the corresponding side. So to make sure that these are similar, we would simplify these fractions. Well, simplifying the fractions is one way. Another way is to cross multiply, but these are big numbers, and I don't feel like writing that stuff out. So let's try to simplify. See, 18 and 25, I can only divide 25 by 5 and itself, and I cannot divide 18 by 5. So right now those, I can't simplify that. This one right here, let's see, I can divide this one by 9 and this one by 9. So this would be 4 and this would be 5. So that's 4 over 5. And there's no way I'm going to be able to simplify 18 over 25. So these are not proportional. That means they're not similar. So are they similar? No, because the sides are not proportional. Let's look at number 2 here. We have two right triangles again. We want to see if these are similar. Well, this is a 30, 60, 90, and this is a 30, 60, 90. And because they're both 30, 60, 90s, I know that we have corresponding angles congruent. So let's set up our proportions. Let's do the hypotenuse because that one's kind of obvious that those two sides correspond. So we have 34 over 17. And the other one, let's do the 30 degree side. So because we're doing the 30-degree side, we want to make sure we get the 30-degree side over here. So that's 15. So we're going to go 30 over 15. Okay, so I'm going to simplify both of these fractions to see if they're the same. 17 is a prime number, so that means it can only be divided by 17. So can 34 be divided by 17? And the answer is yes. See, this would be 1 and this would be 2. And then, so on this side, let's do the same thing. Let's divide the bottom by 15, and we'll divide the top by 15, which is 2. So it looks like these are proportional shapes right here, or proportional sides, which means they are similar. So we would say that this triangle is similar to this triangle. The little sign means similar. Okay. For these problems, we're told that the two shapes are similar. So because the two shapes are similar, we can use that information to help us find any missing sides, like that one. So this says that PQRS, that's PQRS, is similar to TUVW. TUVW. Now it's very important how you read that, because the T lines up with the P. So this guy and this guy are the same. And then in this figure we go to the Q next. And in this figure we go to the U next. So this one goes around and names it clockwise, and this one names it counterclockwise. And that's very important because that helps us see which sides correspond to each other. So we can set up proportions. Alright, so we need to know what X is corresponding to. It looks like X is the last side after S. So which is the last side after W? Let's see. It'd be U, and then V, then W, and then 15. So we're going to say X is over 15 equals, and then the 35 is the only other number that we're given on this shape. So which side over here corresponds to 35? Is it going to be the 20 or is it going to be the 25? Well, it looks like the X is right next to the 35. So the 15 is right next to the 25. Then I'm going to say 35 over 25. So we have 35 over 25. Now to solve this, we can use cross multiplication. But first, if I can simplify a fraction, I'm going to do that because it'll make my calculations a little more simple. I could divide both of these by 5, so I get 7 right there and I get 5 right there. And now I'm going to cross multiply. 7 times 15 equals 5 times x. So we got 7 times 15, which is 105. And we divide both sides by x. That's 21. We got our x value. Now this shape is, they're triangles, so let's find the missing side here. Actually, there's two missing sides. We have an x and a y. First, let's set up our proportion for the x. We'll put x over, see, x would correspond to, now this is when I have to read it. It says I, j, k. So we start with I, we'll put a little box around it. I, j, and j is next, so I'm going to put a circle around that one. The next one says LM. We start with the L, so we'll put a box around that one, and we go to M, so I'm going to put a circle around that one. So now it's more clear. It goes from I to J, then the K, and this one goes from L to M, then the N. So the 28 corresponds with the X. So then we have 54. We'll put a triangle around him. Corresponds with, that's not really a triangle, 42. So we have 54 over 42. Now let's double check to make sure everything's related. Now these guys correspond to each other. That's what we figured out. But what about this x and this 54? Yep, the x and the 54 are from the same shape, so we're in good shape. What we set up is accurate. 54 and 42 can be simplified by dividing them by 6. So we get 9 and 7. And then we would cross multiply. So 9 times 28 equals 7x. And then we can multiply these two together right now, the 9 and the 28. There is a shortcut though. I can divide both sides by 7 right here, and when I divide these by 7, I only divide one of these numbers by 7. So we can divide the 28 by 7. That would make it into a 4. So we have 9 times 4 equals x. That was way easier mental math for me. 9 times 4 is 36. Okay, let's look at one more. Maybe. Let me see. Nope, looks like that would be sufficient for what you guys need to do today.